Simple harmonic motion problem number 4 on the WebAssign. We have a cart and it is oscillating with some springs here back and forth. Okay, it's oscillating. It's got some mass m, and the problem says what the omega is, which is the radians per second, and that might be a little odd because we don't use radians per second, so that's probably the most difficult part of this problem. We're going to then put a load in it and see how the basically angular frequency changes. But I just used the term you're not real familiar with, so I'm going to shy away from that and just call it frequency. You know what frequency is? It's cycles per second, it's oscillations per second. Now the connection between the two is simply this. Frequency is equal to omega, the radians per second, over 2 pi. Because radians per second, there's 2 pi radians in a complete circle. 2 pi radians is equal to 360 degrees. When you go around a circle, you're doing one oscillation. All right, so that might have been a little confusing because, again, we haven't worked with that, but 2 pi radians in a circle makes the frequency related to the radians per second like this. So if there's a whole bunch of radians per second, there's less complete cycles per second because it takes 2 pi radians to make a complete cycle. Okay, that was a long intro to that thing. We've encountered it before. But what we want to do then is, with this idea in mind, let's see how, we want to know how the frequency then depends on the mass m. How does frequency depend on mass? Well, let's go with our formula for the period, which is 1 over frequency. Period, time per cycle, cycles per period of time, okay, is F. So they're just inverses. And the period of an oscillating system like this is 2 pi square root of m over k. Therefore, the frequency is equal to 1 over 2 pi, still a constant, square root of k over m. So that's what the frequency looks like. Because this is a constant, then frequency is proportional to the square root of, the k is constant, it's not changing, 1 over m, the square root of 1 over m. That's how the proportionalities relate. Now because frequency and omega are just connected with this constant, we can then say that omega is proportional to, I'll do it this way, 1 over square root of m. So take your value of m, and if we put this in a ratio, basically it looks like this. Well, I'll do it the simple way. Omega prime, the new omega, is equal to 1 over the square root of m omega. That's all there is to it. If you put, omega prime over omega is equal to 1 over the square root of the new mass divided by 1 over the square root of the old mass. And that's the same thing as this. All right, and so this becomes the square root of m over the square root of m prime. This is good enough. This is just showing it with a little more detail. And that'll give you the answer that you're looking for.